have a look at this improper integral. Here we're asked to evaluate the integral going from 1 to infinity of the function 1 over x dx. It's an improper integral because we have this infinity sign in one of the bounds of the integration. So what we're going to do is we're just going to remind ourselves what that infinity sign actually means. And that is, instead of having the infinity sign up there, what that is actually trying to tell us to do is we're going to replace that infinity sign by n. So we just have 1 to the power of n. And then at the end of our calculation, we're going to let the limit as n goes to infinity. So this is what the improper integration symbol means. And so now we're going to do this definite integral here. We can just use our regular definite integral laws here, and then we'll just take the limit as n goes to infinity at the end. So the antiderivative of 1 over x, of course, is just ln of the absolute value of x. Okay, and we're going to evaluate that from 1 to n. So if we actually go and substitute those values in, this becomes, we plug in our n, ln of the absolute value of n, minus what we get when we plug in 1. Okay, so that's our definite integral. And of course, because n is going to infinity, n is a positive number, we're going to start at some number n, and we're going to keep going, increasing without bound. So n is some positive number. So the absolute value here of n, we can get rid of the absolute values because this is a positive number. And of course, the absolute value of 1 is just 1. So we can actually get rid of those absolute values. So we have ln n minus ln of 1. And of course, the logarithm of 1 is just 0. So that's just 0. So we have the limit as n goes to infinity of ln n. So now we ask ourselves, what happens to the log function as the numbers that you plug into the log function get larger and larger and larger? And of course, the log n just gets larger and larger, so this diverges. One can think that this limit is equal to infinity, although I don't really like thinking of things equal to infinity. The idea is that as n gets bigger and bigger, ln n just keeps getting bigger and bigger. So this integration never actually goes to any sort of number. So this just diverges. So this improper integration is divergent.